In Unit 5, we'll be talking more about these trigonomic identities that we've already gone through in previous sections. Let's start with some of the ones that we've already seen before. Reciprocal identities, sine and cosecant are reciprocals of each other, cosine and secant are reciprocals of each other, and tangent and cotangent are reciprocals of each other. Then for the quotient identities, tangent is sine over cosine, and since tangent and cotangent are reciprocals of each other, as we've seen just now, that means that cotangent is cosine over sine. For the Pythagorean identities, I've got sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. I've also got these cofunction identities and even odd identities. These ones are a little bit tougher to memorize, but sine of pi over 2 minus u equals cosine of u, and we can also say that cosine of pi over 2 minus u equals sine of u. So these two are connected here. Tangent and cotangent, similarly, tangent of pi over 2 minus u equals cotangent of u, cotangent of pi over 2 minus u equals tangent of u. And then secant and cosecant, similarly, secant of pi over 2 minus u equals cosecant of u, cosecant of pi over 2 minus u equals secant of u. Then for even odd identities, the sine of negative u equals negative sine of u, cosine of negative u equals cosine of u, tangent of negative u equals negative tangent of u, and then cosecant of negative u equals negative cosecant of u, secant of negative u equals secant of u, and cotangent of negative u equals negative cotangent of u. Okay, that was quite a bit. We'll be referring to these as we go throughout these problems today. So we've got a few just simplification problems here. We've got simplify the following expressions using trigonometric identities. Number 1. Cosine times tangent. All right, well, tangent is sine over cosine. So what I like to do is start out with, is there anything I can do to get rid of tangents, cotangents, make it just sines and cosines? Because if I can make it the simplest, just sines and cosines, I can usually get rid of a bunch of things. So let's start there. Let's change tangent to sine over cosine. So this will now be cosine of x times tangent is the same as sine of x over cosine of x. Well, now, if I say that cosine of x here is cosine of x over 1, then I can see that these would divide out, leaving just sine of x. Okay, what about secant of x times cotangent of x? Again, I want to kind of see if I can change this to sines and cosines. If I can change this to sines and cosines, maybe things will divide out. So the secant of x is the same as 1 over cosine of x, since they are reciprocals of each other. So let's start there. This is 1 over cosine of x times cotangent of x, we saw earlier is a cosine over sine. So this is going to be cosine of x over sine of x. Right now, cosine on the bottom here, cosine on the top here. These will divide out. This leaves 1 over the sine of x, which is the same as saying cosecant of x. All right, number 3, sine of pi over 2 minus x times the secant of x. Well, we saw earlier that whenever I've got this pi over 2 minus x, I'm going to refer back to these cofunction identities. So the sine of pi over 2 minus u equals cosine of u. Well, instead of u's, I'm using x's here. So this will just be cosine of x times the secant of x. Secant and cosine are reciprocals of each other, so this will be 1 over cosine. Now I think of this cosine as cosine over 1. This is 1 over cosine. These will divide out, leaving just 1. All right, last one here. Tangent of negative x times negative sine of x. Okay, so these are my even and odds. Tangent of negative x is the same as negative tangent of x. So this will be negative tangent of x times negative sine of x. Now I can go ahead and see if I can get rid of tangent, make it sines and cosines. So this will be negative tangent is the same as sine over cosine. So this will be sine of x over cosine of x times negative. I can think of sine as sine over 1. All right, what's this give me? Negative times a negative is going to be a positive. And then let's multiply top times top, bottom times bottom. So positive sine times sine is going to be sine squared over cosine times 1 is cosine. And we will leave it like that. Okay, it continues to say, one common use of trigonometric identities is to use given values of trigonometric functions to evaluate other trigonometric functions. So example, use the values of secant of x equals negative 3/2 and tangent of x is greater than 0 to find all 6 trigonometric functions. Okay, so let's start here. I already know secant of x is negative 3/2. So let's just fill out what we know. This is negative 3/2 here. Okay, and then I know that cosine and secant, these are reciprocals of each other. So if secant is negative 3/2, then I can say cosine is going to be negative 2/3. Okay, now what can I do? I know that sine squared plus cosine squared equals 1 from my Pythagorean identities. Let's write that over here. Sine squared plus cosine squared equals 1, which means that to find sine, we can manipulate this a little bit. And if we subtract cosine squared from both sides, then we'll get something like this. Sine squared equals 1 minus cosine squared. Well, I know that cosine is negative 2/3. So this is the same as saying 1 minus negative 2/3 squared. Okay, so this is 1 minus negative 2/3. Negative 2 squared is going to be 4 over 9. All right, then I say 1 is the same as something over itself. Since this denominator is 9, I can change this 1 to be 9 over 9. That means that sine squared is 5/9. And therefore, sine is going to be the square root of both of these. So I will end up taking the square root here and the square root here. And I'll get sine is the same as the square root of negative or square root of 5/9. Okay, square root of 5/9. It says here that tangent has to be greater than 0, though. So here's the thing. If I take the square root here, I will technically get a positive or negative square root of 5/9, right? So if I go here, taking the square root of sine squared will give me sine of x equals positive or negative square root of 5/9. Except it also says that tangent is greater than 0. So I have to be thinking about that as well. If sine is positive square root of 5/9, okay, positive, then cosine being negative, sine over cosine, that would make tangent negative. So that means that sine cannot be positive. Sine must be negative, because if sine is negative and cosine is negative, then tangent being sine over cosine would be positive. So that means I'm going to reject this positive answer here, and sine of x is going to be negative square root of 5/9. Okay, and actually I can go one step further than that. I can actually take the square root of 9. I can say sine of x is equal to negative square root of 5/3. Okay, then let's find cosecant. That's going to be the reciprocal of sine. So that means flipping this upside down. Let's do that over here. That's going to be negative 3 over the square root of 5. I want to rationalize that denominator. That's going to make this negative 3 square root of 5/5. Last thing to find is tangent and then cotangent. Okay, I know tangent is sine over cosine. So the tangent of x equals sine over cosine. That means that this will be sine is negative square root of 5/3. This is all over negative 2/3. Okay, well, I can divide out these 3's, and then negative over negative will be positive. So what's left is square root of 5/2. Then for cotangent, we're going to find the reciprocal of tangent. That's going to be 2 over the square root of 5. All right, let's rationalize the denominator here. So this will end up being 2 square root of 5/5. All right, so a lot of these problems can look very complicated, but once you're more familiar with your trig identities, they become a little bit easier to work with, to a point where you just kind of know what to do for a lot of these. When you're simplifying, change everything to sines and cosines, see if you can divide things out, and then write what's left over. For problems like this, use a lot of your reciprocal identities, and knowing that tangent and cotangent are sine over cosine and cosine over sine respectively, and that'll help you out with finding a lot of these trig functions and identities.